Chapter 16 Momentum Methods. In Chapter 15, we learned the principle of work and energy is a very useful tool in mechanics. We can derive another useful tool for the analysis of motion by integrating Newton's second law with respect to time. We express Newton's second law in the form summation of the force is equal mass times dv dt. Then we integrate with respect to time to obtain this equation, where v1 and v2 are the velocity of center of mass of the object at times t1 and t2. The term left is called the linear impulse, and mass times velocity is the linear momentum. This equation is called the principle of impulse and momentum. What is the principle of impulse and momentum? The impulse applied to an object during an interval of time is equal to the change in the object's linear momentum. The dimension of the impulse of a force are force times time, and the unit for the impulse of a force are Newton second. By introducing the average of the total force with respect to time from T1 to T2, the principle of impulse and momentum can be expressed in terms of the average force. This is a very important equation that we use for solving many problems. What is impulse and non-impulsive forces? Force acting on a particle during a very short time interval that is large enough to cause a significant change in momentum is called an impulsive force. While non-impulsive force or force for which F times delta T is small and therefore may be neglected. And for finding the impulsive force, we use this equation. Look at this figure. When a baseball is struck by a bat, contact occurs over a short time interval, but force is large enough to change sense of ball motion. While the weight of the baseball is very small. For example, for this reason, this one is a non-impulsive force, and this is the weight, and we can neglect it. Let's look at some examples. The jumper approached the takeoff line from the left with horizontal velocity of 10 meters per second, remain in contact with the ground for 0.80 seconds, and take off at a 50-degree angle with velocity of 12 meters per second. Determine the average impulsive force exerted by the ground on his foot. Give your answer in terms of the weight of the athlete. From problem, we know that the V1 is 10 meters per second and V2 is equal when the jumper takes off at a 50-degree angle with velocity of 12 meters per second. We have to find the average impulse force in terms of W. First, we have to draw impulsive and momentum diagram of the jumper. After that, apply the principle of impulse and momentum to the jumper to determine the average impulsive force exerted on the foot. We assume this force acts to the left. Okay, first I write the impulse momentum equation in the x direction. The V1 in x direction is 10 meters per second and V2 in the x direction is V2 cosine 50 degree. Now we can find the average impulse force in x direction. The force exerted to the jumper in x direction is the force of ground to his foot. For y direction, V1 is 0 and V2 is V2 sine 50 degree. The force exerted to the jumper in y direction is the force of gravity, or W, and force of ground to his foot in y direction. After we solve this equation, the average impulse force exerted by the ground on his foot in x and y direction are negative 1.295 W in x direction and 6.21 W in y direction. Next example. A 4-hole baseball is pitched with a velocity of 80 feet per second. After the ball is hit by the bat, it has a velocity of 120 foot per second in the direction shown. If the bat and ball are in contact for 0.015 seconds, determine the average of impulsive force exerted on the ball during the impact. Again, we have to apply the principle of impulse and momentum in terms of horizontal and vertical component equation. First, I write the impulse momentum equation in x direction. The V1 in x direction is 80 foot per second, and the V2 in x direction is V2 cosine 40 degree. Just look at here, and the mass times V1 is negative because the direction of the ball is in negative direction, and we find the force in x direction is 89 pounds. For y direction, the V1 is 0 and V2 in y direction is V2 sine 40 degree. So the impulse force exerted on the ball during the impact in y direction is 39.9 pounds. Now we have to find the magnitude of the force because we have already found the force in x and y direction. So the magnitude of the force is 97.9 pounds. Last example. A car weighing 4,000 pounds is driven down a 5-degree incline at a speed of 60 miles per hour. When the brakes are applied, causing a constant total braking force of 1,500 pounds. Determine the time required for the car to come to a stop. Okay. Again, apply the principle of impulse and momentum. The impulse is equal to the product of the constant force and the time interval. The velocity of car is 60 miles per hour, and so V1 is 60 miles per hour. But we have to convert to US customary unit system. So the velocity is 88 foot per second. The velocity of car after apply brake and stop it is 0. So the V2 is 0. Now we have to write all impulses force that parallel to the incline. We have the weight in the incline. We have W sine 5 degree, and also we have the braking force that against the motion. For this reason it's negative. Now, after we solve this equation, we find the time. The time is 9.49 seconds that require for the car to come and stop. Thank you for watching.